Recording, and this is the last part of the lesson, or whatever it was. I think it was just graphs of something. Graphs of sine and cosine and tan. This one is sketch a graph of tan x. Am I the right one? Yep. For 0 to 360. Yeah. Oh, you did.
Mis calculadoras are there.
Okay, yeah, use that one. Draw a graph of tan x for 0 to 360. I think I did it on here. So if you're not sure of it, so you could do it on your graphing calculator. Let's practice it. You go to y equals, type in tan x. Do they want degrees or radians? Degrees, yeah. So I don't know why I've got the other thing there. Oh, that's because of a later question. So mode, make sure I'm in radians. So see, I'm going to have to change to degrees. Hooray.
Oh, yo también.
I'll get rid of that second one. I don't want that. Yep, so tan x, yep. And I need to adjust my window. Then I'll adjust my window. So it's roughly from -10 to 360. What was that, Owen?
My calculator died and I lost my calculator charger.
I have one.
There's a shorter in the common room?
I have one in my bag right here.
Can I use it, please?
So I'm adjusting, guys, notice I'm adjusting my window now so that it matches 0 to 360. But so I can actually see the y-axis, I'm doing -10 to 360. My mode's in degrees. I probably want to adjust my window so it kind of looks like this, -3 to -3. Sorry, -3 to 3. So my y-min, let's make it kind of match a bit so it looks like it's all going to be in scale. -3 to 3, so roughly -10 to 360. And then let's graph it, and then you know roughly what it should look like. Can anyone remember what the period of a tan graph is? Is it 2 pi, tan x, or is it pi? It's pi, yeah. Because sine and cos, if it was sine x or cos x, the period's 2 pi over 1, so just 2 pi. If it's tan x, it's half of it, it's pi. So it's going to repeat itself every part 180 degrees. Remember tan x's, they have asymptotes. Do you remember they have asymptotes as well?
Yeah.
Does anyone? So it's going to repeat itself. So it starts here, and it's going to repeat itself again over at 180 because it's got a period of 180. So maybe it's, you know, period equals 180 degrees for tan x. So it's going to start here. Oops, start here and go up, and then it repeats itself sort of around 180. And they have asymptotes, because remember tan x, I've got the unit circle thing there. I'll just calibrate again quickly, because the unit circle, tan is undefined at certain points. And what is the, can anyone remember what is the trigonometric identity? Just from trig identities, tan theta equals?
Sine over cos.
Good, yeah. So to make tan theta undefined, what?
It has to be over 0.
Yeah. Exactly, yeah, cos theta has to be 0. And where is cos theta 0 again?
90.
Yeah, and 270, yeah. From 0 to 360 for sure, good. So where are our asymptotes going to be?
Those exactly.
Yeah, exactly, good. Because so we can kind of put in new little asymptotes. So that one's at, this x, yeah, x equals 90 degrees, and x equals 270. At that point, cos x is 0, and that means that the denominator is 0, so undefined. So notice that you can tell by the way it's kind of graphed on the calculator that it looks like it sort of starts here, which it does, goes up, then it starts again here and goes up. So that distance has to be 180 degrees because the regular tan x has a period of 180. Yep, so we know that it starts here again. It's going to start here again, so maybe I should put in a blue point there as well. So a little blue point there. And then you just kind of roughly sketch it according to what you see. So notice it kind of increases a bit, so it kind of goes up. If you want to, you could find an exact point if you like, but just a rough sketch is okay. Goes up, and then it kind of goes up, swerves around here and goes up, and then it goes up here. But don't sketch it beyond kind of like 360. So kind of like goes up like here. Oh dear. here it's kind of going down, and here it's kind of going up. Draw it better than I did. Make it look more like the one on your graph. It's hard to draw on the laptop. There we go. So it's got some asymptotes and stuff. So we just did a nice little sketch of 10x between 0 and 360. So that's why we didn't go beyond here, because it just wanted it to 360. And then part B says, on the same set of axes above, sketch tan x plus 45 minus 2. So what does the 45 tell us in terms of transformations?
It got shifted to loud.
And how many degrees?
45.
So shifts the opposite direction, yep. 45 degrees, yep. And the minus 2, what does that tell us?
It's vertical. Shift down.
Yeah, it shifts down. So what you could do is, it's a bit of a pain. Like, at least we know the asymptotes. We know the asymptotes for this one will shift left 45 degrees. So they'll be kind of in the halfway point. So you could shift all the asymptotes. The period's still going to stay the same because the thing is still 1. It's a number in front of the brackets. And each of these little points, we want to shift down 2 points. So it is kind of confusing. I'll start to do it. I've got 2 things here. I'll start to do it on here.
How come you said it shifted left?
Yeah, shifts left because in the brackets is where the horizontal translation is. Whatever's added or subtracted.
Why do you put degrees? Because I guess we're just using degrees for x.
Yeah, because x is degrees. Yeah, it's not the end of the world if you don't write the degrees. So I'll just I want in green first. So I'm going to do this one in green just so when I look back and this. So in the end, your graph's going to look like a bit of a mess because you've got so many things on it.
This one, I keep trying to graph my thing and it says arrow window range.
So what have you got in your window? X min?
Oh, never mind. I put x min at 360 instead of negative 360. I put
I see. Okay. And then this one's going to shift back 45 degrees. So that's going to be about here, isn't it? And so that's it. So 45. Got on this right. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Is that 6? Yep, there's going to be another asymptote here. Such pain. This is a painful one to do. We might just talk about this one and not graph this one because it's getting messy on the graph. So these are all asymptotes. So where would they be? So I'm doing this one in green. So this one would be 45 degrees to the left of that one. So that's why the x equals 45 for that one.
Yeah,
I don't have that one.
That's what I was confused.
Yeah, you're right. Well, I didn't have that one. What am I doing? Sorry. I don't know what I was doing there. Zoning out.
Bro. Wait, so what are you doing?
So this one, yeah, this one's fine. So this one here is fine because it's that one moved to the left. This one we don't need. That's better. Don't know what I was doing there. No. So yeah, see the asymptotes are kind of like every whatever.
Which one are you erasing?
The one there. Yeah. So we should only have one at 45 and one at, I think, is that 225? Yeah, 180 plus 45. Yeah. 270 minus 45. What's 270, girls? What's 270 minus 45?
235. I'm lying. 25.
225 degrees for that one. And each of those little points, it's off, so I'll do the points on here.
When is the Boolean?
Yeah, it's never, not this one. So notice each point, it's going to shift, each of these points shifts 5 degrees left and 2 points down. So take this point, go 45 degrees left. So on here it's about 3 boxes and 2 boxes down. So that's where that point's going to move to. Pretty painful. And this one goes 45 degrees left and 2 points down. Okay. So we can kind of draw this first one here. We'll only draw one of them because it's a bit This one goes down. This one kind of goes up. Make sure it doesn't cross your asymptote. And from this one, it starts to go down. Whoops. Down. There. You guys drawing? You graph?
Yes.
And then so that one, the green one here. So the points move 45 degrees left and 2 points down. 45 left and 2 points down. Then do that and that. And then this one's gone down and kind of up. And then this one, there'll be a little bit left over of this bit. There's going to be a bit of this thing kind of happening. Yeah, hard to see, isn't it?
The green one, you get over closer to the asymptote, like where it starts.
Oh, there's no the asymptotes to the green one now.
Right, but because you see how the green graph is still stopping at the red one?
Yeah.
Wouldn't it
Oh,
be
yeah.
stopping closer to the green one?
Yeah, but probably further down. Because remember, this whole thing shifted down, so it's going to continue down, like further down in the graph, like down into lower values. It's going to kind of like start to, like this thing will start to do this.
Why does the
If you want this kind of like.
graph kind of go like a crease?
It looks awful. It does. But
Why does the green graph go like below? Why doesn't it stay
down
because see down to.
Shouldn't it?
oh down to
Yeah, so each point, like those little middle points that we had here, I went across to the left 45 and down 2. So this point here got shifted across to the left 45 and down 2. And then I kind of drew a
for
range.
the next intersection?
Yeah, for the next little bit. Right.
Across to down to?
Yeah, so here's the
Yeah,
old
those
point.
look on man.
So see here, remember we were saying that before?
I wish I was moving.
Yeah, we were saying that stuff before. Let's go.
Okay.
Yeah, so we won't draw the second one, we'll just talk about this one. What the 0.5x, what's that going to do to our period? It's an interesting one. The 0.5x, is it going to make our period wider or is it going to make our period closer together?
Is this one where it is 1.0.5, it's like to be double it kind of? Because it's inverse?
Guys, listen. What's
Is
that
it,
say?
this one's inverse,
Yeah,
right?
yeah,
So
exactly.
That's going to be wider.
Yeah, because dividing by something like 0.5 doubles it, doesn't it? Yeah, so both of you are right. So Sarah's also right. It's going to become, the 0.5x is going to become wider, make it wider.
So
And the reason is like,
stretch.
yeah, exactly. So as Sarah said, it's going to make the period wider. And the reasoning is because of what Krista said, because the period's related to the reciprocal of 0.5. And dividing by 0.5 is like doubling something. If you divide by a half, it's like timing by 2. So this is going to make the period wider. So the period will now be doubled. So period will be doubled
This one, I mean.
as 1 divided by 0.5 equals 2.
That green one, where does it go to the green line?
The green one. Where does it go into the y? I just did it
That
backwards.
one.
That one?
The first one.
That one?
First one.
That one?
Yeah.
Where does it go into the y? I just tried to replicate what we did here. So I'm just doing it vaguely. There's no exact correct point. You could, if it was with a graphing calculator, you could find the y-intercept by.
Because we don't have enough space to go by 45 degrees, so like we can't really.
Yeah, and the period says don't go before 0 degrees. So that's why I tried to replicate roughly what they had on that one here, and then try to replicate it. If you want to know the exact value, you can get it on the graphing calculator. You go second calc value and sub in 0. So that period will be doubled. The 3, like we tend to, like it's not like a sine and cos graph where the 3 affects like an amplitude. We don't so much have like amplitudes with tan graphs.
Computer.
Yeah, so we don't so much have amplitudes in tan graphs. But what it will do is it kind of will make it rise up and drop down faster, at a faster rate. So the 3 will make it increase at a triple the rate it did before and decrease at triple the rate it did before. So we'll make it change at triple the rate. Wow, that's a really bad spot on the board.
We didn't say that before. We said something else. We said that was a vertical.
Vertical stretch. Yeah. Okay, so you could say it stretches it vertically. Yeah, that works well too. I'll have to scroll down so it actually right. Remember, as I said, you don't have amplitude in tan graphs. Yeah, because remember, like sine graphs, you do have amplitude, like you have maxes and mins. The tan graphs, there is no max or min. It just keeps going up, keeps going down.
So it just gets up fast.
Yeah, and down faster. Yeah, exactly. A triple the rate. So if you want to write that in whichever way you like.
Oh, so that's why you didn't say the vertical thing.
Yeah, but yeah, that's a good point. You could say vertical stretch of factor. That's a good point that you can just say vertical stretch of scale factor 3. Interesting how it writes properly when you write on that board. Or like Tilly said, it goes up faster and goes down faster, like triple the rates it did before. There is no amplitude because with tan graphs, there's no max or min. They just go up infinitely and down infinitely. And that's that. I'll just quickly stop and start converting this one because it'll convert nice and fast then.